Okay, so previously we have covered turn in place animations. If I quickly show you the demo, so now we have this nice looking turn in place, right? So before implementing this turn in place animation, actually there was a foot sliding, but since now we have a proper root based turn in place, that foot sliding has been gone, right? So now what we can do is we can improve our start animes further, because one thing is, like, if I swap my character's rotation mode to forward facing, like in here, and if I play it, I will see before changing the direction, the character is playing a wrong start anime, right? I mean, it's not wrong, but it's not accurate enough, right? So ideally the character should try to turn to that specific direction instead of playing the start anime rotating like here, right? So actually the rotation happens with a minor foot sliding. It's not actually the animation that has been played. So now what we are going to do is basically replace that logic with some set of animations, and then it will not improvise this sort of a foot slide. And if I change the character's movement mode to crouch, again sort of a start anime is playing, which is fine, but let's see whether we can improve this further or not, right? So as the first step, let's go to the ABP locomotion anim graph, locomotion state machine, and start. And here we have set up start anim layer, right? So there, really this is how we get the start cardinal direction based on the data table. But if you look at, there are set of animation start with echo. All right, let's say idle to joke. Yeah, maybe I think we have to import set of animations. So I quickly pause this video and import this real quick and come back again. Okay, so I imported set of new animations. So the first set of animation that I imported was this echo animations. Actually, these are taken from the echo sample project that Unreal Engine officially released. So they are set of animations that we can reuse to achieve our forward resolved animations. So if you go to this starts category under mail, we have those animations, right? For example, let's say this one is right to forward, right? These sort of animations we can use to resolve that forward animation. Plus, addition to that echo animation collection, I have created a new folder called Paragon. So there actually I'm going to reuse the animations that the Paragon characters have. So actually Epic released years ago many Paragon characters. So there are very useful animations on those assets. So in order to organize those stuff, this Paragon folder will hold all those relevant animations based on for each character. So I think previously it has this Greystone character based animations, and I add this Sparrow character based animations as well because it has this nice looking bow animations. So we can reuse these animations to maybe later on to implement some bow as a weapon, things like that, right? And then Now let's go to here, and so now this function will be a bit more cumbersome because we have to handle multiple different logics. Therefore, instead of adding all of those logics inside this setup start anim function, let's create a new function to get start anim separately. Okay, so I'll select all of these nodes and let's collapse to function, and I'll call it as get start anim. This should be a pure function and thread save. Compile save, and if I go to the function implementation, this is what we have, right? Okay, now we have to implement set of new structure here at our data table to get start forward cardinal direction animations, forward facing cardinal direction based animations. Okay, right. So before modifying any sort of fields at our data structure, let's first export this thing. Otherwise, in case if there are any sort of data mismatch, our data will be corrupted and everything will be lost. Therefore, for safe side, let's export as JSON as this file. So we have the latest dump of this data table. Now, now let's go to our data structure movement, right? So let me look at my documentation real quick. Inside this movement, let's create a new blueprint structure called as anim forward facing start. Okay, so here let's add an anim sequence called start forward, right? This is just a direct forward start, and then we need start forward left 90 and right 90 and L 180 and R 180. Okay, then let's go to the anim movement data structure, and here let's add a new variable called start forward facing. Right, and I'll move everything to here. Save all. We are good to go, and anim set also good to go. Plus data table, and let's go to the blueprint component. This one, compile, save. Okay, now in the data table instance, let's see whether we have lost anything. All right, but I think this data structure is wrong. Why is that? Yeah, because here we haven't select this forward facing data structure. Let's select it like this, and then save all to go. Oh yeah, this one has broken, right? So let's reassign it. Should be movement group, right? So that data structure has been broken. Movement group, yeah. This comes with is any movement. This one is good to go. This one is broken. Right. So let's quickly reset everything and set it back. Movement, save. And then let's go to the movement SNM set. This should be the movement group. Save. And now if I save this, yeah, we have those cardinal directions, but obviously the data has been lost. But first let's go to this component and compile it again and save all. Right. So nothing to be worried because we have dumped this data table. Therefore, let's re-import it. And these warnings are obvious because our data table JSON file doesn't have these sort of records because we have just now added those stuff as new records or new fields. So let's simply click OK, and now rest of the data will be populated accurately. Okay. Now we have to set start forward facing animations. So I'll start with maybe jog start forward facing. So there are a set of animations that we have to plug here, but as the first start forward anim, actually we can plug the exact same start that we have attached to here because it's just a default start, but from this fields onwards we can use those echo animations. So in echo, let's search for echo idle to jog, right? Echo idle to jog. Here we have left 90, right 90, and left 180 and right 180, right? Plus I think these animations have some root motions that has been enabled. So let's go to the directory and disable those stuff. Not this one, actually this one. Detection, edit property via property matrix, root motion, enable root motion tick, force root lock tick, and save. Right, now this animation doesn't impose any sort of root motions. Okay, then let's go to here. Now we have to get our data structure. So therefore we have this not thread safe set animation data, and inside cardinals, it's not ideally a cardinals, so therefore I will create new record by copying this one, new collapse nodes actually, right? And it should be start forward facing. Start forward facing. I'll assign it to the anim sequence category. And let's set a new pin right after and here, and I'll collapse the nodes and says forward facing starts. Okay, now we have forward facing starts, compile and save. Let's go back to the get start anim helper function. Right. Okay. Now let's get that data structure reference and split it. Right. And now now first actually we have to determine whether we are at strafing or forward facing. So in order to distinguish that, actually we can use property access get movement component orient rotation to movement. Right, so if this is true, which means we are in forward facing manner. If this one is false, then we are strafing. So let's add a select node here, and as the rule I will plug this one. And if this is false, we can use the existing implementation. But if this is true, then we require new implementation. Okay. Right. So do we have a reference called last direction? Because we need to determine the last direction. Yes, we have. So let's get this last direction instance. And if you look at the find references, this is the place that we set the last direction initially at the on acceleration changed call. Plus for each start anim layer, we are recording whatever the last direction after that frame has been rendered. Right. Okay. So we can use this as a select to get some of the anim sequences. Right. So yeah, for forward actually we can use this one again because it should be work for the sprint as well. But if you're not sprinting, you are taking the existing forward and pass it to the forward. Right. And for the backward, again let's have a select, and we have last velocity direction, and if this one is a positive value, then it means this is a 180-degree turn, right? Therefore we have to show this R 180 turn. So I will plug it here. So if this one is true, we can show our 180 anim sequence, else we can show L180 anim turn. Right, that's the second logic to determine the backward start. And for the forward, actually left and right start, then we can simply use L90 for left and R90 for right. Okay, that's the first step. And we have a cached curve. So we have the reference for turn your curve value. But I think maybe we can catch this thing for each frame, right? So let's go to this acceleration change dispatcher event listener, and there let's first check whether we are playing start anim or not. So if we are not playing start anim, then there is nothing to be cached. But if we are playing the start anim, then we can cache the existing turn your curve value. Promote to variable catch turn your curve value. Okay. Because actually this turn your curve value will keep updating when we are applying the root turn in place animations, but this cache turn your curve value will store the latest or previously captured turn your curve value without interrupting it, right? So we have the reference for that specific turn your curve value at the very first frame before that turn in place animation has been applied. That's why we have to cache this value. And I think we can move 3 of these variable to the turn in place category. Compile, save. So we have that cache reference. Go back to the get start anim function, and there let's check whether our cache turn value is not 0, and if it is not 0, let's make another select to here, and if it is not 0, if it is true, then we can select this sprint logic based forward animation. If it is false, we are using this one. Okay, and finally it applies to here. So there are a set of conditions that has been applied. First, it will check whether we are sprinting. If we are sprinting, we are playing the sprint animation. We are not considering any sort of forward facing start animations. And if you are not sprinting, then we simply check whatever the direction that you have been forward to. So if it is forward direction, then you are playing the forward animation. Else, based on the left or right, we play those animations based on the last captured direction. And if it is a 180 turn, then we play the L180 or R180 animation based on this check, last velocity direction check. And we check the catch turn your value as well. And finally, we plug the to this select, and here it will check whether we are strafing or forward facing. If it is strafing, then it will play this one. If it is forward facing, then it will play these ones. Okay, we have this animation, so I will move it to the anim set category. Wait. Okay. So we plug that function to at our setup start anim layer. So do we have the state node function for start as well? Yeah, we have a state node function for setup start state as well. So let's go to that function. Setup start state. Okay, I think those functions are safe, but let me quickly look at my documentation. Right. So actually there is one to do function at the setup start state function that we have to implement, which is this one. So actually I have been added this to do function in a earlier episode, because this can be further improved, right? So currently it's check for the last direction. If it is forward, then we are simply mark it as reached end of turn. And since now we have forward faced based start animations, actually we can get some use of it as well. So first we can check our start cardinals forward with the get start animation, and if both of these are true, then we can add another logic, something like this, right? And I can remove this. So basically what this does is it checks the cardinal directions for the forward facing rotations, and it will mark it as determine this reached end of turn state character state data, right? Okay, now I think this should work. So let's play test it again. So we are the forward facing mode. Okay, now you can see we don't have foot sliding anymore. Instead of that, we have a nice smooth animation playing for that specific direction, and the turning also works very smoothly, right? There is no unnecessary turning animation that has been played because we have improved this logic, right? So since this variable is now sensible, or now sense for these forward face based start anim instances as well, anim sequence instances as well, it will not play unnecessary turn in place anim sequences, right? So it actually resolved two issues. First issue was the foot sliding and unnecessary, I mean like start anim playing. That's the first issue. And the second issue is unnecessary turn in place animation that was been playing before. But right now both of those issues has been fixed. But I think actually we are playing female animation at the forward facing start state, right? So let's go to the data table. So here you can see this echo character is actually a female character, but currently all of our animations are male character based animations. That's why it sort of look like a female movement, but I think that would be fine. It is almost unnoticeable, right? Okay, now that's for the jog, but if you look at the walk state, you can see it's for the T pose because we haven't added the animations for that. Therefore let's go to the data table instance again, right? So here we can use this what forward any as this one, and rest of them we can use the echo animations. So echo idle to walk, we have this left 90, right 90, left 80, and what, right 80. Okay, save all. Let's go to the walk mode. Yeah, I can see like we have proper animation that has been played. Okay, how about the crouch mode? Yeah, the crouch mode also we have to resolve. Let's go for the crouch. But I think we don't have any echo animations for crouch, right? So how to resolve if it doesn't have any animation? Yeah. So if it doesn't have any sort of animations to be played, then what we can do is we can actually replace this stuff based on with the idle animation. So it won't ended up with TPS like before. So let's go to the ABP locomotion anim blueprint, and I think the get start anim function, I was directly using this start forward facing data structure reference. Instead of that, let's create a new data structure called looking direction, and we can resolve it at the initialization stage, and we can pass that reference to here to play the proper animation, right? So at the initialization, actually we have this set animation data function, and at the forward facing starts, yeah, let's first check. I'll break this thing. No, actually I will keep everything as it is. Let's use this thing which is start forward facing, break it, and we can check that this is valid or not, right? And maybe let's promote this to a variable again called in direction. I move it to here and unpin this one, make it again, and here let's select. So if this one is valid, then we can simply play this one, else we can play the idle anim, which has in here idle anim. Why it can't be plugged? This should be a name sequence type. Let's change the variable, compile. Yeah, just a type mismatch, right? So it in the anim sequence type. So if it is false, we are playing the idle animation, right? So similarly, for each animation we have to make this lookup. Okay, this one, and this one. Okay, so if it is true, then no issue, we can play the exact animation. If not, we are playing this idle animation. Right, then simply plug those to here. Okay, so it will resolve the animations before it is passing. Right, actually the code looks a bit unclean. Therefore what I can do is maybe I can promote this to a macro. and null this one, maybe this function. We can promote, since it's using the same forward anim, let's attach it like this, and let's collapse to a macro. I'll name it as m check anim validity, right? So the pin one is anim to be checked, and the second one is maybe, let's say, optional. Okay, so if the anim to be checked is valid, we are playing that animation. If otherwise, we are returning the optional anim. Okay, now maybe I'll remove all of these pins, and instead let's use this one. The name optional anim is basically idle anim. The anim to be checked is this one. We don't need this one. Maybe we can move it up here, and we can attach it to this forward. Okay, let's make alignment to the left and distribute vertical. Okay, so basically now each of the animations has been checked. So if the animation is valid, we are attaching the correct animation. If not, we are simply attaching the idle anim. Then let's attach it to the execution pin at here. So we have this looking direction. Compile and save. Let's go back to the start anim. And instead of using this one, let's use this looking direction, break it, and let's attach everything properly. This one is forward, left and right, left 180 and right 180. Okay, let's compile, save, and test everything again. Yeah, so for jog it's working, for work also it works, right? And for crouch, yeah, the animation is playing, but it keep remaining at that specific end, and then it start to play. Yeah, I think fix is quite simple. So here actually let's go back to the what, set animation data, forward facing start. So actually I have added this idle animation as the optional anim. So if the animation is not valid, we are simply trying to play the idle anim. But actually this is not quite accurate enough. Instead of that, let's plug start cardinals. And there, let's break it, right? And let's use this forward anim instead of this idle anim. can plug it like this. Okay, let's remove this one and I'll hide the unconnected pins. Move it here. Right, now let's try crouch again. Yeah, now it works properly, right? So if it doesn't have animation to be played, then we can simply play that start and start cardinal forward and right. So the crouch work, jog also work, and walk also work. But actually, for walk, actually that feline movement is almost noticeable. But there is actually nothing we can do about it because the provided animations are actually female oriented animation. So if you are creating a like DT anim set female data table, then these animations would be really useful. But for a male animation, I think it may not be quite accurate enough, but just for the testing purposes, it would be fine, right? And at the jog state, actually, it's pretty much nice, right? Even if it is a female anim, it's almost not noticeable, right? Yep. So let's look at the data table anim again. Data table anim set again. Maybe do we have any other animations? Idle to walk forward, right? Yeah, actually, this anim is for mapping is wrong, right? Because L180 should be right 180. So maybe that's why it causing that weird issue of foot sliding at the walking. So let's switch it back to left 180. And I think rest of them are pretty much okay. So let's save and play it again. Yeah. Now actually that sliding issue has been gone. And it works properly. Right, maybe we can add some braking acceleration as well, because whenever we stop, actually the acceleration should reach to 0. But at the configurations, actually I have been added only the max acceleration, so it's simply applying that acceleration only. Those improvements we can do later on, but for now I think this episode covers this forward facing based start animations, and it works pretty much fine. And I'll see you in the next episode. Thank you.